SmartNexxie-AI Smart Parking System. AI-powered parking analytics, blockchain verification, RAG assistant, and Power BI integration. SmartNexxie is an end-to-end intelligent parking management platform that unifies computer vision, IoT sensor streams, retrieval-augmented prediction, RAG, and blockchain verification through Microsoft Fabric's Lakehouse and Event Stream. This solution integrates YOLOV 8, PySpark, vector embeddings, MCP governance, and Power BI dashboards for real-time monitoring, AI-assisted predictions, and explainable analytics. Project overview. Component description 01 underscore. Complete underscore setup underscore and underscore data sets up. Fabric delta tables, ingests, IoT data streams, and synthetic traffic datasets 02 underscore A. I underscore processing underscore predictions, runs, YOLO detection, AI inference, RAG embeddings, and blockchain verification, 03 underscore monitoring, underscore dashboard. Monitor system health, KPIs, and real-time insights using Event Stream and Spark. 04 Power BI Advanced Analytics. Generates Power BI metrics, data marts, and predictive business insights. 05 underscore Y. OLOV 8 underscore visualization. Visual, AI demo for live parking video detection, and RAG explanation assistant.
Alright. SmartNexxie is an AI smart parking management system. Here, as you can see, this is the folder in GitHub. The SmartNexxie, see the description of the SmartNexxie. See the technology using the blockchain verification, RAG assistant, Power BI. The description of the is one of the SmartNexxie is the end-to-end intelligent parking management system that unifies computer vision, IoT systems, sensor streams, retrieval augmented prediction, and blockchain verification through Microsoft Fabric Lakehouse and Event Stream. This solution integrates YOLO, PySpark, vector embeddings, MSP, governance, and Power BI dashboard for real-time monitoring and AI assisted prediction and analytics. Yeah, these are the main folders, as you can see. The description. I'll take you through them. Let's go through them each by one. Yeah. So now the system architecture. This is the system architecture. IoT system, event stream, Fabric. Yeah, pressing YOLO. Yeah. Let's see the architecture. System instruction with the folder structure. See the folder structure is that one. The module, the description of every part. Yeah. Monitoring and dashboard part, because stream. Will be advanced analytics. You can know everything has been everything query. Going technology stack. I say the technology stack from data injection to AI models, governance, security, analytics, BI, visualization, front end, storage, orchestration, language and framework, KPI and alerts, occupancy. Yeah, RAG retrieval accuracy. You can see the KPI and alerts, the licenses, the holder, and the holder. The future roadmap, deploy, duration, RAG system, integrate live web socket, add EV versus non-EV classification, master traffic flow prediction, build level. Yeah, that's all with the GitHub. Let me take you through the Microsoft Fabric. This is Microsoft Fabric. So I was telling you. I will dwell mostly on the Lakers because I'll explain later that the notebook detail by detail. Let me first dwell on let me show you the workspace. This is a workspace. This is the workspace, as you can see. The workspace, we have several folders. These are the main folders, as I told you. The event strip, these are how the data was generated. I generated the data synthetically. since the data they could have the IoT that sensors to print the data directly. But I just for simulation purpose, I did use my own data for simulation purpose. Yeah. So this is a RAG assistant platform, which I will explain a little later in my notebook. It's a visualization using lawyer. This will dwell mostly on computer vision. Explain on detection and how to obtain the, the the parking zones, which are coordinates. I'll show you the data which I created. Yeah, for to assign the space. I'll show you the visual of the project of the model later on. Ah, that's all with the. Let me take you to the. Let me go back. I want to take more on data. To dwell on this data because this data is not available in the GitHub, but it's a very essential data, which was some of which was generated from the notebook. As you can see, this was generated. This was just generated. Yeah, this was synthetically generated data. This is the main data, synthetically generated. Yeah, this the Power BI insight. You can see the Power BI insight. Yeah, the YOLO processing. Yeah, let me show you an example of the data like this one. I don't think take time to open. Will it open? It take time. Take time. It will take time to open. But the visuals, I'll show. The visuals are attached on in my screenshot. I'll attach them in my GitHub. Okay, let me go further to the notebooks directly. This is the first notebooks, as you see. The lakehouse connection. Already we have created a lakehouse manually. You have to verify the lakehouse connection. The step 2 is to clean up existing tables. This is where we see the drop-in tables. Yeah? Create a fresh table. Yeah. The generate synthetic data, which I told you, since we are using simulated data, you have to show how the sensors works. Yeah. You can see the reload data to lakehouse. It's a fixed version. Yeah, you're loading data, the loaded data, then a data quality. This is about data cleansing, cleaning of data, wrangling, small wrangling of data. That's all. That's all. That's all. Yeah, that's a step one. And then the enhanced version. This is where I used a data, the blockchain version, and this model context protocol and Power BI. These are technologies which are enhanced in this from above. It's 'cause they are the same, but they are pretty the same, but they have used blockchain. I've added blockchain and other technologies which are needed. Yeah, you can see the output. So the table are dropped. The table here is stimulated, generated a synthetic data. The synthetic data is ended up generated from. You can see that the topics. These are a data account transaction. Yeah, data transaction. But hope you you will understand about data. Data is a blockchain technology. It's a immutable technology. It's mostly used for security purpose. Yeah. Generating power. Yeah, that's the output of the data. I don't dwell. I will not dwell on the because you know that implement. This is a higher processing prediction where you get you verify the data which exists. Yeah, yeah. The image processing of your computer vision, mostly used by electrolytics for object detection. And it can be using object counting. Yeah, you'll see how it works in my demo. Okay, this is a RAG traffic prediction. You can see how they implemented it. Yes, go down. Yeah, you can see how we got performance analysis. Everything a bit down. This for AI processing, further processing on high process. The output, verifying the processing, everything. This is the number of the prediction results sample. See the zones. These are the zones. The zones. You see the zones which are parking zones. Yeah. Okay, parking now. Everything. The data have been okay. Analysis. Everything's done. Enhance. This is an enhanced version which you do the data MSP and Power BI. Yeah, the approach is the same, but you understand that the output will be more improved. Eh? Yeah, you can see the registry. So some of them, the data which will be which we saw them on in the park in the lake house. These are generated from here. Yeah, let me check you to the third, which is the monitoring dashboard. Yeah, this is the environment checkup and health checkup. Okay. It's a one about health checkup. See the system overview. Everything is yeah. Record checkups. See the zone parking zones. So the parking zone are very. You see how this parking zone will be. Just the model. Yeah, everything generated successful. The model has been successful. This is the data using the improvised version. Yeah, you can see everything has been it's working as expected. I'll take you finally to the. Finally, I'll take you. Sorry for that. Finally, I'll take you to the RAG assistant. The RAG assistant, these are mostly for querying the model. The model, you have to train the model on how to predict. So let me show you how they have. See how they have approach. Usually uses transformers. Yeah, use transformers. You can see the approach here. It's implemented. Everything is implemented. It's working expected. Yeah. It's easy using the MSP for querying tools like a data ledger, a data manager is a tool which usually you need we've been queried here. Yeah, you can see this is a question which question can you occupancy the answer. The answer is displayed here. All the retrieved documents are mentioned here. This modules with embeddings and vector store are all usually are within the I usually utilize here. I think that's so with rag. Yeah, let me take you through. I don't think there's anything there.